Pushpita Sanda. I am a PhD student at IIT Delhi under UKLR program, joint collaboration of IIT Delhi and University of Queensland. So I am a TA for today's session, Mathematical Methods in Physics 1. So let us start with assignment number 6. So the first question is, find the general solution of the differential equation d2y dx2 minus 3 dy dx plus 2y is equal to 2x square plus ex plus 2x e to the power x plus 4e 3x. Okay, so first we need to know the complementary function. So complementary function. For complementary function, we need to solve the the equation as a homogeneous equation. 3 dy dx plus 2y is equal to 0. So let us assume y is equal to e to the power mx. So this equation will become m square minus 3m plus 2 is equal to 0. So it will become n minus m square minus m minus 2m plus 2 is equal to 0. So m minus 1 into m minus 2 is equal to 0. So m is equal to 1 and 2. So complementary solution will be c1 e to the power x plus c2 e to the power 2x. Now we need to find particular integration. Or yp. Let us assume here we can see in the second hand, here we have a exponential term ex and e3x, also polynomial term x square, and also a polynomial x and ex. So we will assume yp will be for polynomial of degree 2. We need to assume that it will have a part like this, and for exponential, for the part of exponential e to the power 3x is there also. So we will assume a constant g e to the power 3x as none of the m is 3. And as we have seen that for e to the power x, for kind of d minus 1, d minus a, d minus b, if e to the power a or b x, solution will be x into e to the power x into c. So we will assume another part x e to the power x into, there will be two parts because there in second hand there will be an ex for that it is f, and there is another part x ex, for that there will be a dx or x square into ex. So we can write this. For polynomial part, we will assume a part a x square plus bx plus c. For e to the power 3x part, we let us assume this kind. We need to need to obtain the value of constant a, b, c, here g, and for x e to the power x part, and also for e to the power x part, as there is a value a or b, one of them is equal to c according to the class. So here there will be a x square e to the power x with some coefficient, and only x into e to the power x with some coefficient. So it will be, write that as bx plus c plus x e to the power x dx plus f plus g e to the power 3x. If this is yp, or we can write that x square fx. So yp satisfies the equation, so we need to know dyp dx, which will be 2ax plus b plus 0, because we know e to the power x dx square plus fx plus e to the power x 2 into dx plus f plus 3 into g e to the power 3x. Okay, d square yp dx square will be 2a and 0 plus e to the power x, then dx square plus x into f plus 4d plus 2 into f plus g plus 9 g e to the power 3x. Putting all that in the given equation, dy square dx d2y minus d2y by dx2 minus 3dy dx plus 2y is equal to 2x square plus e to the power x plus x into e to the power x, there is a 2 plus 4 e to the power 3x. So yp will satisfy this equation. So this should satisfy the right hand side. X plus 4e 3 to the power x. So we will plug d2yp by dx2, which is 2a plus e to the power x d into x square plus x into f plus 4d plus 2 into f plus g plus 9g e to the power 3x minus 3. We know what is dyp dx, which is 2ax plus b plus e to the power x into dx square plus f plus 2d into x plus f into 3 e to the power 3x plus 2 into that yp is equal to will be that. So after simplification, the left hand side will be 2a plus e to the power x dx square plus x into f plus 4d plus 2 into f plus d plus 9g e to the power 3x minus 3 2ax plus b plus e to the power x dx square plus f plus 2d into x plus f plus 3g e to the power 3x minus 2 into ax square plus bx plus c plus e to the power x dx square plus fx plus g e to the power 3x is equal to, we will get 2x square plus e to the power x plus 2x e to the power x plus 4 e to the power 3x. Now we will write this equation of the left part of the equation as a coefficient of x square e to the power x, x into e to the power x and e to the power 3x. After bunching this kind of thing, we will get 2x square plus 2b minus 6a into x plus 2c minus 3b plus 2a plus x square e to the power x into 2d minus 3d plus d plus x into e to the power x 2 to the power 2f minus 3f plus 2d plus f plus 4d plus e to the power x into minus 3f plus 2f plus 2d plus e to the power 3x will be 2g minus 9g plus 9g. This will be equal to 2x square plus e to the power x plus 2x e to the power x plus 4e 3x. By comparing the coefficients, we can see there is no term of x square e to the power x on the right hand side, so this term will be 0 and it has become 0. Okay, there is no constant term, so it will be 0. We will get a condition from that. 2a will be 2, 2b minus 6a, it will be 0 because there is no term containing x at right hand side. 2c minus 3b plus 2a, it will be 0. Okay, the term coefficient with x to the power ex will be equal to 2, and with the term with e to the power x will be equal to 1, and 2g will be equal to 4, so g is equal to 2. So can write 2a will be 2 which mean a is equal to 1. 2b minus 6a will be 0. That means b is equal to 2 by 6 by 2 into a, which is 3. Third condition is 2c minus 3b plus 2a is equal to 0. From that we can see 2c is equal to 3b minus 2a, which is 9 minus 2, 7. So c is equal to 7 by 2. Then the second condition will be minus f plus 2d is equal to 1, and minus 6d and plus 4d is equal to 2, which will be d is equal to minus 1. So f will be minus 3, and 2g is equal to 4. So g is equal to 2. So particular integration will be y yp is equal to x square plus 3x plus 7 by 2 minus e to the power x square plus 3x plus 2 e to the power 3x. The whole solution will be y is equal to yp plus ycf will be x square plus 3x plus 7 by 2 minus e to the power x square plus 3x plus 2 e to the power 3x plus c1 e to the power x plus c2 e to the power 2x. Okay, now we are given equation that at x is equal to 0, y is equal to 15 by 2, and at x is equal to 0, dy dx is equal to 9. So at x is equal to 0, y will be 7 by 2 minus 2, this term will be 0, plus c1 plus c2, and this is 15 by 2. My 7 by 2 minus 2 will be c1 plus c2, 4 by 2. So c1 plus c2 will be 2. To obtain dy dx, which will be c1 e to the power x plus c2 e to the power 2x plus 2x plus 3, here it will be 2 minus e to the power x square plus 3x minus e to the power x 2x plus 3 plus 6 e to the power 3x. So at x is equal to 0, this is c1 plus 2c2 plus 3 minus 3 plus 6, and this is equal to 9. c1 plus 2c2 plus 6, so c1 plus 2c2 is equal to 3. c1 plus c2 is equal to 2, c1 plus 2c2 is equal to 3. From that we can say that c1 is equal to c2 is equal to 1, and we need to obtain at x is equal to 1 what will be y. So we know the full version of y here. c1 is equal to 1, c2 is equal to 1. So y will be 2e to the power 3 plus e to the power 2 minus 3e plus 15 by 2. This is the answer. So let's move to the next question. Mark all statements that are true, which is e to the power x and e to the power minus x are linearly independent solution of the square y and the x square. So d square is equal to y, d square minus 1 to y is equal to 0. So this will be d plus 1 and 2d minus 1 to y is equal to 0. So if y is equal to e to the power mx, it will be m plus 1, and m minus 1 is y is equal to 0. So solution will be y is equal to c1 e to the power x plus c1 e to the power minus x. So they are actually linearly independent solution, which is the first statement is true. The second statement is y is equal to c1 e to the power x, and is a general solution of that equation. It is a homogeneous equation. We can obtain that part very easily. 3dy dx plus 2y is equal to 0, y is equal to e to the power mx. So it will be m square minus 3m plus 2 is equal to 0. We have already solved the equation at the previous question, so we know it is true. So we can write that y is equal to c1 e to the power 2x plus c2 e to the power x is the solution. We can extend c1 and c2, that's up to us. Third question is the solution of d square d2y dx2 minus 4dy dx plus 4y. d2y dx2 minus 4dy dx plus 4y is equal to 0. Again it is a homogeneous equation. Y is equal to e to the power mx, that will make m square minus 4m plus 4 is equal to 0, which is m minus 2 whole square. We know if the root of this equation is equal, then y is equal to c1 e to the power 2x plus c2 into x e to the power 2x. So c is also true. Let's try D, which is if y1x is a solution of that equation, the equation is d2y dx2 plus a dy dx plus by is equal to 0, then derivative of y1x is also a solution. If derivative of y1 is also a solution, then y1 is a solution, so we know it is a true. If we have to prove the derivative of y1 is also solution, we have to prove dx2 dy1 dx plus a d dx dy1 dx plus b dy1 dx is 0. We need to prove that. This, and we note this. if we take derivation of this, so we will get d3y1 dx3 plus a is a constant, d2y1 dx2 plus b dy1 dx is equal to 0, which can be written as d square dx square dy1 dx plus a d dx dy1 dx plus b dy1 dx is equal to 0. So we can say if y1 is a particular a solution of the equation, then the derivative is also a solution. So we can remember it also as a information. So all these are true. So using method of variation of parameters, find a particular solution to the differential equation. So the differential equation is d2y dx2 plus y is equal to cosec x. First we need to obtain the general complementary function. Which is CF. For that we need to have the solution of homogeneous equation, which is d square plus 1 is equal to y, or we can say if is equal to 0, if y is equal to e to the power mx, this equation will become m square plus 1, y is equal to 0, m will be plus minus I. So into that, y complementary function will be e to the power 0x a cos x plus b sin x. Okay, so to find a particular integration using variation of parameters, we assume that yp is equal to v1 sin x plus v2 cos x. It is equal to, we can write c1 sin x plus c2 cos x. Okay, so we need to satisfy the differential equation. For that we need dyp dx, which will be, it is also can be function of x, it also can be a function of x. So dv1 by dx into sin x plus v1 derivative of sin x is cos x plus dv2 by dx cos x minus v2 sin x. Can assume dv1 dx sin x plus dv2 dx cos x is equal to 0. So dyp dx will become v1 cos x minus v2 sin x. Again we need d2yp dx square, so again differentiation dv1 dx cos x plus v1 cos x it will be cos x, here it will be v1 sin x minus dv2 dx sin x minus v2 cos x. Putting these things in equation, we get dv1 let us give the name of equation. In equation A we get dv1 dx cos x minus dv2 dx sin x minus v1 sin x minus v2 cos x plus v1 sin x plus v2 cos x is equal to cosec x. So this is done. So we get dv1 dx cos of x minus dv2 dx sin of x is equal to cosec x. Okay. We have already gotten dv1 dx sin x plus dv2 dx cos x. So from this either we can obtain the value of dv1 or dx and put the value in the previous equation, then we will get dv2 or v2, or we can do alternative. So dv1 by dx will be cos x by sin x dv2 dx. We know dv1 by dx cos x minus dv2 dx sin x is equal to cosec x. Putting this value, we will obtain cos square x sin x dv2 dx minus sin x dv2 dx is equal to 1 by sin x. So it will be cos square x sin x dv2 dx minus sin square x by sin x dv2 dx is equal to 1 by sin x. So it will be cos square x plus sin square x dv2 dx is equal to 1. So dv2 dx is equal to minus 1. Is equal to minus dx, so v2 will be minus x. Putting this value in the dv1 in this equation, we'll get dv2 dx. We already have say minus 1, so dv1 dx will be cos x sin x. Cos x by sin x. So let us assume sin x is equal to u, then in the differentiation of u it will be cos x d is equal to du by u, which is ln u. So here ln u is sin x, so it is sin x. Sorry. So v1 is equal to ln sin x and v2 is equal to minus x. I want to mention one thing. We have done all this calculation and came to this solution. v1 is equal to ln sin x and v2 is equal to minus x. If you want to keep it, it is good for proper question, but for MCQ type of question, if you want to remember v1, which is equal to, if we know if complementary function is c1 y1 plus c2 y2 and particular integration we have assumed v1 y1 plus v2 y2, then v1 is equal to minus rx y2 by Wronskian of y1 and y2, and v2 is rx y1 by Wronskian of y1 y2. Here what is rx? The second order differential equation can be written as like this: plus px dy dx plus qx to y is equal to rx. Here r is x is cosec x. Okay, and we have already obtained that our complementary function is c1 sin x, okay, sin x plus c2 cos x, which is y1, which is y2. Then the Wronskian will be is y1 y2 y1 dash y2 dash, so it will be sin x cos x minus sin x, which is minus 1. So v1 will be minus r is cosec x, here it is minus 1 into y1 is sin x. No, that is y2. Cos x. So it will become like that, which we have known, that is x v1 is equal to ln sin x. But see, this is involved less calculation, and the Wronskian part you can do all this in a minute. And for v2 it will be okay cosec x by minus 1 into sin x dx, which will be minus dx, which will be minus x, which we have got there, but this is less time taking. So the whole solution will be ycf plus ypi, which is ln sin x into y1, which is sin x minus x cos x plus c1 sin x plus c2 cos x. So we can write this y is equal to sin x log of sin x. So from this we can write, if we have given solution like this is particular integration, we know, but we didn't have any condition, so we don't know if there is c2 is equal to 1 or not. Next question is, for the following differential equation correspond to different oscillators subject to external drives, that is forced oscillation. Ideally all these are identify all those that are being resonantly driven. So we need to remember for this a resonant condition, which is root over omega square minus 2b square is equal to omega naught. Okay, so condition for this kind of oscillation is root over omega square minus 2b square is equal to omega naught. And what is omega and 2b? The equation of this kind of oscillation can be written as d2x dt square plus 2b dx dt plus omega square x is equal to function of some function into cos omega naught t. Okay, so we need to compare this equation and obtain what is 2b and omega square. Literally omega square is root over k by m, constant, and this is mass. Those things you need to remember, but here we are not bothered about k and m. We only need omega and 2b and omega naught, and we need to find those for every equation given. So the first equation is d2x dt square plus 2dx dt plus 4x is equal to 2 cos root 2t. We compare, we know 2b is equal to 2, omega square is equal to 4, and omega naught is equal to root 2. Let us see what is omega square minus 2b square. So b is equal to 1, you know that. Omega square is 4 minus 2 into 1, which is root 2, which is equal to omega naught. So this is resonant condition, and this equation satisfies the resonant condition. So A is true. For the next equation, it is this, it's d2x dt2 plus 4dx dt plus 9x. is equal to 2 cos root 3t. Here 2b is equal to 4 omega square, sorry, not omega naught, it is omega square is equal to 9, so b is equal to 2 and omega naught is root 3. So root over omega square minus 2b square, omega square is here 9 minus 2, b is equal to 2, so b square is equal to 4, which is 9 minus 8, which is 1, but omega naught is here root 3, so it is not satisfying the resonant condition. Option number 3 is d2x dt square plus 6 dx dt plus 25x is equal to 2 cos root 7t. Here omega square is equal to 25, 2b is equal to 6, so b is equal to 3, b square is equal to 9, omega naught is equal to root 7, so omega square minus 2b square will be 25 minus 2 into 9, which is 18, 25 minus 18 is 7, which is omega naught, so it will be resonant frequency, that will be root 7 will be resonant frequency, and the oscillation will be resonantly driven. Equation number D is d2x dt square plus 8 dx dt plus 36x is equal to 2 cos root 5t. So here omega square is equal to 36, 2b is equal to 8, so b is equal to 4, b square is equal to 16. Omega naught is root 5, so we see omega square and 2b square is what? Omega square is 36 into, it is 0. Okay, now 32. 36 minus 32, which is 4, which is 2, it is not equal to root 5, which is omega naught, so it is not resonantly driven. So equation 1 and C are the answer. So suppose we wish to find a particular solution of the differential equation. So here it is said that we want to find a particular solution. We can do by any method. So this equation can be written as d square plus d minus 2 into y is equal to the power x. For complementary function it is d square plus d minus 2 into y is equal to 0. If y is equal to the power mx, m square plus m minus 2 is equal to 0, m plus 2m minus m plus 2 into m minus 1 is equal to 0. So m is equal to minus 2 and 1. The complementary function can be written as c1 e to the power x plus c2 e to the power minus 2x. For particular solution, so we need to assume a yp. Okay, so we know the rule. If t minus a b for cx yp for cx some constant if c not equal to a not equal to b x into c to the power cx if c is equal to a or b but a not equal to b, and x square c e to the power cx if c is equal to a is equal to b. Here e to the power x, here c is equal to a, we can say, then we need to assume that x into a c to the power ex, sorry, c into a e to the power cx, here c is 1. Okay, so we need to dyp dx. Here also we can obtain the solution.
Hello, ma'am.
Yes.
Ma'am, বলছি যে সেকেন্ড কেন প্রথমটা তো পাওয়া উচিত ছিল?
Okay, no, it will not be the first one. You are saying that why it is x into e to the power x, not only e to the power x, right?
Yes.
Yes. Here what is the condition? D minus a into d minus b is if d minus a into d minus b is equal to e to the power cx, when a, b and c all are not equal, but here we have already seen that this equation d square plus d minus 2, I have written same equation instead of d with m, that is m plus 2 into m minus 1, right? So we can say it is d plus 2 into d minus 1. So if we see, and it is e to the power x, so here is, if we regard is a and here it is c, a is 1, c is also 1. So c is either equal to a or b. This condition is satisfied, right?
ও আচ্ছা, আসলে আমি ভেবেছিলাম c equal to a by b হলে তবে করে
No, it's or, sorry, it's my bad, it is or. See, go through the class material, okay? Here you can also do with separation of parameters, or that there is another kind of solution I will mention just after that, but you need to remember what you need to assume first, otherwise you will not getting in the correct solution. Okay, dyp dx is equal to a e to the power x plus x a e to the power x. d2yp dx2 will be a e to the power x plus a e to the power x plus ax e to the power x. Now we need to plug all this thing in the mother equation, which will be, or you can say d2yp dx2 is dyp dx minus 2 2y p is equal to 0, so it will be a e to the power x 2 plus x plus a e to the power x 1 plus x minus 2a x e to the power x. Oh sorry, it's not 0, it is e to the power x. Only e to the power x. So the term x into a to the power x, and here it is x into a to the power x minus 2a x e to the power, it will be 0. So we will have only 3a e to the power x, which is equal to e to the power x. To satisfy this, a should be 1 by 3. So yp will be 1 by 3 x e to the power x, and the whole solution will be c1 e to the power x. Okay, whole solution will be c1 e to the power x plus c2 e to the power minus 2x plus 1 by 3x e to the power x. So we can say it is a form of alpha x plus beta into e to the power x. Okay, and this kind of solution we should try. We have tried what, x into e to the power x, but we have already seen that here in the complementary function we get c1 e to the power x. So even if we consider plus something constant, let it be e to the power x, even then we will end up like this kind of solution. So it will not alter the solution, and we will not get a different kind of solution, because we have already obtained that e to the power x part for complementary function, and we know that plus e to the power x, how many times we have like add, and then if we satisfy the boundary condition which is not given here, we will get the correct constant coefficient with that e to the power x. So here it is the only solution where x into e to the power x is the option. So we this kind of analyze we should try. Okay, now I am to mention something else. This kind of extra. Here we only like we try the solution using two methods. One is variation of parameters and undetermined coefficient. But if the main concern of us is to have the particular integration, we can also use D operator. What is D operator? If a equation is differential equation is given, like here it is d2y dx2 plus dy dx minus 2y is equal to e to the power x, we can write it d square plus d minus 2 y e to the power x, right? This is a function of d, or we can say d operator. So y will be 1 by f of d e to the power x. Now how can we have solution of that? Okay, there is some simple rule. 1 by f of d e to the power alpha x will be 1 by f of alpha e to the power alpha x when f of alpha is not equal to 0. If f of alpha is equal to 0, then we need to replace it with f dash alpha, and in upper hand we need to introduce a x into e to the power alpha x, but here f dash alpha should not be equal to 0. If ff alpha and f dash alpha both are 0, is 0, f dash alpha is 0, then we need to introduce f dash dash alpha, then here would be x square e to the power alpha x. Okay, so here what is our f of d? D square plus d minus 2. Here d square plus d minus 2 e to the power x. Here if we compare f of d to the power alpha x, f of alpha, what is f of alpha? 1 plus 1 minus 2, which is 0. So we need to introduce f dash alpha. Okay, what will be f dash alpha? We need to know first f of f dash d, which is 2d plus 1. Here if we put f dash alpha will be 2 alpha plus 1, which is not equal to 0. Great. So it will be x into e to the power x f dash alpha, which is x into e to the power x, 2 alpha plus 1, here alpha is 1, it will be 3x into e to the power x. See, we have already obtained this term 1 by 3 x e to the power x. So in this method, here also you see that when f dash alpha is also 0, we need f dash alpha x square e to the power alpha x. When will be f dash alpha 0? When will be f dash alpha is equal to 0? When c is equal to a is equal to b. F of d is nothing but d minus a into d minus b. F dash alpha or f dash d at d is equal to alpha will be 0 only if c is equal to a is equal to b. We have already seen that then only we have to also assume it is a form of x square e to the power alpha x. And f of alpha will be 0 when c is equal to either a or b is equal to 0. Okay? If there is any confusion, you can ask. Yes. Tell me.
এই কোর্সের উপরে নয়, আমার নিজের সিস্টেম আছে, মানে আজকে সিস্টেম করতে।
Okay, I will discuss those in the later part of the class. Okay.
Okay, ma'am.
Okay, so this d operator using obtaining a particular integration using d operator, you can see in some books like mathematical methods by H.K. Das, and there are also some condition, not only this 3 rule is there, so you can go through that. It will be helpful for MCQ type of question or some special kind of question. So question number 6, which is the following differential equation correspond to different oscillators subject to external drives. In each of this oscillation, the external frequency omega naught is tunable. Identify all those that cannot be resonantly tuned. Okay, it is same as some previous question. So we know that or the equation equation should be the form 2b dxt plus omega square x is equal to f of cos omega naught t, and for resonance it will be omega square minus 2 omega naught. Let us see what are the equation here. The first one is d2 x dt square plus 10d. So here 2b is equal to 10, b is equal to 5, omega square is equal to 10. Here omega naught we need to obtain, which is what is omega naught. So omega naught is equal to omega square minus 2b square. Omega square is 10, 2 into b square is 25, so it is 10 minus 15, which is a complex number. Okay, so it cannot be tuned. Omega naught should be positive number, that's why we can tune. Like we know the value of a something, root 3, root 2, root 1, root 4, whatever t, but we don't know value of cos of something imaginary. We don't know. So move on to the next equation, which is d2x dt square plus yes, hello. Tuned means that if it is not in a resonance, you can make it on the resonance. You can change it. Okay, by changing omega naught, you can come to the resonance frequency. Here tune means that. Okay, is it clear now?
Yes, ma'am.
Okay. Then dx dt plus 20x is equal to cos omega naught t. So here omega naught square is equal to 2 omega square, sorry, b is 10, b is 25, b square is 25. So root over omega square minus 2b square, which is 20 minus 50. Again it is an imaginary number, it cannot be tuned. Okay, for C also the 10 dx dt is plus 30x is equal to cos omega naught t. Here also b is 5 and omega omega square is equal to 30. So root over omega square minus 2b square, which is 30 minus 2 into 25, 30 minus 50. It also has I component or imaginary component I to root 20. Here I into root 30. For t also it is d square x dt square plus 10 into dx dt plus 40x cos of omega naught t. B is 5. For all the option B is 5. Now omega square is equal to 40. So root over which is omega naught. Omega square minus 2b square is equal to 40 minus 50. It is I root 10. So none of them cannot be resonantly tuned. So identify all those that cannot be resonantly tuned. None of this. So everyone is correct. Each one of these 4 options cannot be resonantly tuned. Consider a differential equation of form like this. If y1 and y2 are 2 particular solutions, which of the following must hold? y1 is equal to y2, y1 minus y2 must be a solution of a corresponding homogeneous differential equation. y1 is equal to cy2 where c is constant, and y1 minus y2 is equal to c function of x where c is a constant. See, y1 is equal to y2. It is not always, so it cannot be a true. y0 is not always the multiple of y2, so it's also not true. We have seen those. We have seen a couple of solution already. So we know that A and C is not always true. When y1 is equal to y2, we introduce a x there. So they are not independent. If y1 and y is equal to y2, they are not independent solution. So try let us see if B or D or both are true. So y1 and y2 are 2 particular solutions. So they each will satisfy the equation. Function of x. And also we know d2y2 dx square plus a dy2 dx plus dy2 equal to function of x. Okay, if we subtract from equation 2 to 1, we will get d square by dx square y2 minus y1 plus a dy2 minus y1 by dx plus dy2 minus y1, which is equal to 0. So y2 minus y1 or y1 minus y2, also we can take minus common and that will be adjusted, will be the solution of this homogeneous equation. We can see that it is a homogeneous equation. So y1 minus y2 must be a solution of corresponding homogeneous differential equation. It is true. We cannot say that y1 minus y2 will be constant of sum of function of x. We cannot say that. So this is the right option. y1 minus y2 must be a solution of corresponding homogeneous differential equation. You can also keep it in mind, or you can remember it like some type as if a differential equation, non-homogeneous second order differential equation has 2 particular solution y1 and y2, then difference of that 2 particular solution will be the solution of corresponding homogeneous differential equation. And we also know that the total solution of any second order differential equation is complementary function and particular integration. Complementary function is the solution of the corresponding homogeneous differential equation. So y1 minus y2 is a solution of that differential equation. We know that because we have been told that like the linear combination of two solution is also the solution of the differential equation. We have just proved that y1 minus y2 is a linear combination of y1 and y2. Linear combination doesn't mean always plus. So problem number 8, let d by dx be the differential operator, let c be some constant, mark all the statements that are true. So first, d minus c x e to the power cx, so it is d dx minus c x e to the power cx, so it is d dx x c e to the power e to the power cx minus c into x into e to the power cx. So this will be x into c e to the power cx plus e to the power cx minus c into x e to the power cx, which is e to the power cx. So this is true. Now let us check the second one, d minus c whole square x square e to the power cx. So it will be d minus c into d minus c into x square e to the power cx, d minus c d dx minus c x square e to the power cx, d minus c. So first we will integrate this. So what we will get, c into e to the power cx plus 2x e to the power cx minus c x square e to the power cx. This will cancel. Dx minus c into 2x e to the power cx. So it will be d dx yes
minus c whole square কে আমরা a minus c whole square সিস্টেম নিতে পারি না, b square minus 2b plus.
No, it's not true. A minus b whole square, we have already have seen in previous classes that some operator cannot be written like those. Okay, operator doesn't always follow those rules, so it is better we can write this way. Most of the time that follow. Okay, but not always. Maybe this operator will follow and not all operator. So it will be 2 e to the power cx plus 2cx e to the power cx minus 2cx e to the power cx. It is 2 into e to the power cx. Okay, so it is also, yes, it is also true. like when I say most of the operator or some operator will not follow, it is a d minus c whole square. It is, you can say, differential operator. You can see or say, you can see say that all the differential operator will follow, even this operator is one of those operators. So not all kind of operator will follow this like a minus b whole square is equal to a square minus 2ab plus b square root. See, in the next question they are given like this: d square minus 5d plus. You can break it, or it is always best when you are given to prove that you use the operator the way they have given. So it will be dx2 e to the power cx minus 5 e to the power cx. Like some operator behave differently with different kind of on that thing. If the operator has to be operator change, like if some operator follow the rule a minus b whole square for exponential component, it might not be follow for sin x cos x or polynomial or for e to the power minus x. To keep these things on mind. Plus 6 into e to the power cx. So it will be, we know, c square e to the power cx minus 5c e to the power cx plus 6 e to the power cx. So it is c square minus 5c plus 6 e to the power cx. So it is also true. Now we will see d minus cx square e to the power cx. Square e to the power cx. d dx minus c x square e to the power cx. So d dx x square e to the power cx minus c into x square e to the power cx. So it will be c e to the power cx x square plus 2x e to the power cx minus c into x square e to the power cx. This is 2x e to the power cx. For cx, so here is the 2 missing, so it is not true. The next question is: solve the differential equation that using a substitution e to the power x and solving the resulting differential equation with constant coefficient. The general solution. Here one thing you notice that the coefficient of d2y and dx square is not a constant, it is x square. Give me a minute. Okay, so here it is given as, and also you have also given the hint x is equal to, you need to consider x is equal to ez when you consider this the resulting differential equation. After putting all this value, you will get a second order differential equation with constant coefficient, but it is in its own right is a kind of solutions you need to remember, and you will be given this kind of equation. There will be no hint, so you need to remember how you solve this kind of equation. So the trick is that you need to assume x is equal to e to the power z. So dx dz is equal to e to the power z. So dz dx you can say e to the power minus z. Here the operator is ddx. We need to convert the operator to ddz. Okay, our main motto is to convert ddx to ddz. How can we do that? ddx, we can write it as a ddz into dz dx. It is also ddx, so it will be e to the power minus z into dz. Similarly, we need to convert d2 dx2 to d2 dz2. So d2 dx2 will be ddx ddx. So what is ddx? ddx we have given e to the power minus z ddz, right? Also this ddx can be written as ddz into e to the power minus z, and it will be here as it is. So after having this solution, we will have e to the power minus z d square dz square minus e to the power z plus ddz e to the power minus z into minus 1 whole into e to the power minus z. So it will be e to the power minus 2z d square dz square minus d dz. So d2 dx2 is equal to e to the power minus 2z d2 dz2 minus d dz, and d dx is equal to e to the power minus z into d dz. So putting this in, our initial equation was d2 dx2, that is y, plus x dy dx minus 16y is equal to 8x to the power 4. X is equal to ez e to the power 2z d2y dx2 will be e to the power minus 2z d2y dz square dz2 minus d dz, plus it is e to the power z, it is e to the power minus z d dz. This is y, there will be y, minus 16y plus is equal to 8x is equal to e to the power z, so it will be e to the power 4z. This thing and this thing will cancel, to d2y dz square minus dy dz plus dy dz minus 16y is equal to 8 e to the power 4z. we can see this also cancel. So it is d square y dz d2y, not d square, d2y dz2 minus 16y is equal to 8 e to the power 4z. Now it is a second order differential equation with constant coefficients. Now we know how to solve it. So when we have second order differential equation with not constant coefficient, here x square, okay, here x is not constant, but when we put x is equal to e to the power z, the resulting differential equation will be a constant differential equation with constant coefficient. Then we know how to solve this. So we need to remember what is the trick to solve this kind of question, because this kind of question also came in the exam. So now is the same as always. So it is d square y dz 2 minus 16y is equal to 8 e to the power 4z. First complementary function, that will be d square y dz 2 minus 16y is equal to 0. Now instead of e to the power mx, we need to consider e to the power mz. So it will be m square minus 16 is equal to 0, m will be plus minus 4. So y complementary function will be c1 e to the power 4z plus c2 e to the power minus 4z. We need to put the value of z here. What is z? Z is equal to ln x, because we have already assumed x is equal to e to the power z. So z is equal to ln x. So it is c1 e to the power 4 ln x plus c2 e to the power minus 4 ln x. So y complementary function c1 e to the power ln x, we can write it like this, plus c2 e to the power ln x to the power minus 4. So it will be c1 x to the power 4 plus c2 x to the power minus 4. Now particular integration. So here again it is kind of 16y is equal to 8 e to the power, what is that, 4z. It is exponential, okay, and it is d plus 4 d minus 4 and e to the power 4z. So we need to assume x here, not x, z e to the power 4z c or a. So y p will be az e to the power 4z. So dyp dz will be a e to the power 4z plus a 4a z e to the power 4z. d2yp dz2 is equal to, it will be 8a e to the power 4z plus 2 into z 8a e to the power 4z. Putting all these values, we get 8a e to the power 4z 1 plus 2z minus 6az to the power 4 equal to 8 e to the power 4. From looking at this, we know here it will survive only this part. So a is equal to 1. So y particular integration is z e to the power z. What is z? Z is ln x, and e to the power z is, okay, it is 4z. E to the power z total is c1 e to the power 4 plus c2 e to the power minus 4 plus x to the power 4 ln x. Okay, sorry, I've done mistake. Ln x, so x to the power 4 c1 plus ln x plus c2 x to the power by x to the power 4. What happened? So now we will solve the question number 10. So first, complementary function, so it will be d2y dx square plus y is equal to 0. So y is equal to e to the power mx, so m square plus 1 is equal to 0. So m square is equal to minus 1, m will be plus minus I. So its solution is complementary function e to the power 0x into a cos x plus b sin x. You know that. So it is a cos x plus b sin x. For particular integration, we know when dA dB, whatever it is sin x, we can like assume ypi as a e to the power ix. Yes?
Are you right? It's not 0x into a cos x plus b.
Why did I write it? Okay, we know when m is equal to a plus minus ib, we write as a e to the power x, a cos of bx plus b sin of bx. So here we write, we obtain m is equal to plus minus I. A is 0. That's why I write as a e to the power 0x. To make you understand, you don't need to write it. Okay?
Okay, ma'am.
So we can assume particle integral as a e to the power ix. Before, okay, so yp is equal to a to the power ix, dyp dx a into I e to the power ix plus what will be that, okay, ai e to the power ix, again d2yp dx square will be minus a e to the power ix. So when we put these values, in the equation d2y dx square, as we know that we it's need to be satisfied, the equation is equal to minus 2 sin x. So it is minus a e to the power ix, it is plus a e to the power ix, it is 0, it cannot be equal to minus 2 sin x. So there is problem with our assumption. So what should we do? We assume the coefficient, underlying coefficient, as x into a e to the power ix. Okay, sin x, what is sin x? E to the power ix is cos x plus I sin x. When we write sin x, it is the imaginary part of e to the power ix. It is basically imaginary part of e to the power ix, and cos x is the real part. So when time comes, we need to equate the imaginary part of the e to the power ix here. So here dyp dx will be xa into I e to the power ix plus a e to the power ix. d2yp dx2 will be a e to the power ix into I minus xa e to the power ix plus ia e to the power ix. So it will be 2ia e to the power ix minus xa e to the power ix. Now we put in this minus 2 sin x, we can write is imaginary part of e to the power ix. Okay, you don't need to write imaginary part all the time, you need to keep it in mind. Okay, minus xa e to the power ix plus xa e to the power ix is equal to minus 2 e to the power ix, imaginary part. So it is 2I e to the power ix is equal to minus 2 to the power ix. So 2ai is equal to minus 2. So a is equal to minus 1 by I. Minus 1 minus I, it will be I. So a is equal to I. We have assumed particular integration is equal to x a e to the power ix. So x into I e to the power ix. So x I, what is e to the power ix? Cos x plus I sin x. Remember, we have written sin x as an imaginary part of e to the power ix. So the coefficient at the right hand side of the differential equation is the imaginary part of e to the power ix. So whatever calculation we will done after we get a solution in terms of e to the power ix, we will only consider the imaginary part. If it would have been cos x, that it would have been the real part of the e to the power ix. Then after we get a solution in terms of e to the power ix, we would only consider the real part, but here we would only consider the imaginary part. So it become minus sin x plus I cos x. So this is only imaginary part, so we need to consider imaginary part only here. So that solution, actual solution here, ypi is x cos x. If you would have solved the equation as a that method, which is variable of parameters method, so you will get x cos x directly. You would get a variation parameters method, you would get x cos x solution directly, but here you need to consider the imaginary part. So our total solution y complementary function plus y pi is equal to complementary function, we have c1 sin x or a sin x plus b cos x, whatever you can write, cos x plus x cos x. Okay, here a condition is given, what it is that y x is equal to 0 is equal to 1 and y x is equal to pi by 2 is equal to 1. So y is equal to 1 when x is equal to 0, sin 0 is equal to 0, cos 0 is equal to 1, it is 0. So c2 is 1, and from this it is also 1. So 1 is equal to c1 sin pi by 2 is equal to 1 plus, but cos pi by 2 is equal to 0, cos pi by 2 here is also 0, c1 is equal to 1. So y is equal to sin x plus cos x plus x cos x. Now we need to obtain what is y, what is y is equal to when x is equal to pi. So y x is equal to pi will be sin pi plus cos pi plus x into cos pi. It is 0, it is minus 1, it is okay, x is also pi, minus pi. So answer is minus 1 plus pi.
পরের পেজটা দেখাবেন?
পরের পেজটা,
হ্যাঁ,
is this you are talking about?
যেখানে সেই আপনি ইমাজিনারি পার্ট অফ ই টু দি পাওয়ার আই এক্স টা নিয়েছিলেন,
হ্যাঁ, here it is. Why I have taken imaginary part of e to the power ix? Because here it was given sin x. E to the power ix is okay, cos x plus I sin x. So when we consider only sin x, we are considering imaginary part of e to the power ix only. Okay, so that's why I have taken, hello,
ক্যালকুলেশন করার পর ওই জন্য লাস্টে ইমাজিনারি পার্টটা দিলেন আর রিয়েল পার্টটা বাদ দিয়ে দিলেন?
Yes, that's why I have only taken imaginary part after the calculation here. Okay, that's why I
sin x নিয়ে করলে কি অসুবিধা হতো?
হ্যাঁ,
sin x
it will be just a lengthy calculation anything will, if you are doing the right calculation, you will end up getting this calculation. You can do another type of calculation. As long as you are getting right equation, right solution, nothing matters. Okay.
আমার কিছু কোশ্চেন ছিল।
Yes. Now tell me. You can ask me your question. As time is running out, I will get back to you in the next class.
ওকে ম্যাম, আমি স্ক্রিন শেয়ার করি।
Payal, are you presenting anything? Okay, right. I cannot.
হ্যাঁ ম্যাম,
Just make it full size. I cannot see it properly. Or you can send it at chat.
সাতশো টাকা
Huh?
হোয়াটসঅ্যাপ
No. This chat.
আমার
Cannot you see? Actually, I cannot see the whole screen. Right. Just make it a bigger. Yes, now I think it will be good. Just remove me from the screen.
ম্যাম
Yes. Okay.
47
47. Choose the largest eigenvalue of the matrix M. Okay, you need to find the matrix values. Okay. And other questions? I'll get back to you with this trick to solve it immediately. 40? 46. Okay. And only 46 and 47, Payal? Payal? Hello? Only these two?
হ্যালো ম্যাম,
Yes. Hello? You can write in the message box. I cannot hear you properly. There might be some network issue on my side. But 46, 47 and another question. Please show me that question. 33. Okay. Okay, these are kind of series solution, power series. Yes, I will get back to you with this solution in the next class. Okay? Anything else? What? Yes or no?
29.
29, okay. Then
28.
29 and 28.
28.
I have seen 29 next. No, 28. Okay. Okay, this is a okay.
Question.
Okay. That's it.
Alright.
Okay. Show me.
Yes. And the
I can see only 28.
I'm 40.
40.
40.
40. Okay. Then
And
nothing else. What? Is it a question of some?
yeah, so like,
Okay, is this a question of some competitive exam?
yes, ma'am.
Which year and which competitive exam?
Yes.
Just which year?
Yes. Yes.
2016 just. Right?
2016.
2000? Write it in a comment box, please. Actually, I have some network issue. 2015.
8 was today, ma'am.
Okay.
2015.
2023. Okay. I'll get back to you with the solutions in the next class or next to next class, but I'll give you the solutions. Okay. Okay. Then let's call it a day.